All right, today, Unit 3, Lesson 10 is going to be on sample spaces and probability. So I'm going to run through. You can obviously at any time pause the video and copy down these definitions. So I'm just going to mostly be running through the math parts of it, although I'll obviously talk about each one of the pieces along the way. So what we're going to be discussing today is probability, and there are three different types of probabilities that we'll use, mostly just two. There's the classical probability. So what should happen? You flip a coin 10 times, you should get heads 5 times. Doesn't mean you will, but you should. Experimental probability is what does happen. I flip a coin 10 times and I get heads 7 out of the 10 times. Again, not what should happen, but it is what did happen. And then subjective probability is what you think will happen. I'm going to flip a coin and I think I'm going to get 10 times and I think I'm going to get heads 10 times. Subjective doesn't necessarily have to be true. It's just what you think, and we're not going to really deal with that all too much. So one of the things that you need to figure out is what's called a sample space. Sample space is all the different possible outcomes that could happen. So if I were to flip a coin one time, the sample space would be heads and tails. If I flip it 2 times, I could get 2 heads, I could get heads and tails, I could get tails and heads, or I can get tails and tails. And once it gets bigger, you're flipping a coin 3, 4, 5, 6, 7 times, or you're rolling dice, or whatever it is that you happen to be dealing with. Sometimes it makes sense to just draw out the sample space that goes along with that so that you can very easily see how many times something occurs. So, for instance, flipping 3 coins for sample space, possibilities would be to get all heads. I could get heads for the first 2 and then tails. I could get the tails in the middle, or I could get heads first and then 2 tails. So that'd be getting heads first. Getting tails first, heads in the middle, heads at the end, or tails and then 2 heads. So that would be all of the possibilities. So 1, 2, 3, 4, 5, 6, 7, 8. So it'd be 8 of those. Now I just worked through it and figured it out. Well, sometimes that's a little easier said than done. So another thing that you could do is do a tree diagram. And you could say, all right, the first time, so I'm going to start off, I'm going to flip the coin. I could get either heads or tails. Off of each one of those, I could get either heads or tails. And then off of each one of those, I could get heads or tails. So we had 8 possibilities here. 1, 2, 3, 4, 5, 6, 7, 8. Same thing. And you just read down your tree. Heads, 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 tails, heads, tails, heads, heads, tails, tails, and so on. And you'd get the same 8 possibilities that I have there. So if it helps and you're just not able to figure it out very well, drawing a tree diagram would be a good way to do that. All right, the main type of probability we're going to discuss is classical probability. That is what should happen. Again, if you flip a coin, you should get heads 50% of the time. So in your note sheet, there is stuff on cards. So if you're not very good with cards, reference that. You can get where some of these numbers come from, or ask me if you're not getting them. All right. So a single card is drawn from a deck. Find the probability of getting an ace. Well, there are 52 cards in a deck. There are 4 of those, so the probability would be 4 out of 52. I may turn around and ask you to make that a decimal. That's what we're going to do most of the time, or sorry about that, or reduce it as a fraction one way or another. So 1 divided by 13, or 4 divided by 52 to give you the same answer. So about 7.7%. All right, getting the ace of spades would be 1 out of 52. So that would be 1.9%. And then this last one, something we're going to concentrate on a little bit more in the next section, when you've got things that overlap. So I want the probability of getting a 9 or a club. So what I'm going to do is I'm going to count the number of 9s, which would be 4 out of 52. Then the number of clubs, there are 13 clubs in a deck. But the problem is I've counted the 9 of clubs both here and here. So I have to take away that overlap. So 16 out of 52, which you can take and put in the calculator as a percentage. All right. Sometimes it makes sense to do what's called the complement of an event. It means doing the probability of the opposite occurring. So we're going to denote that with a little bar on the top. You're not going to really see that symbolism too much, or most of the time you're going to talk about it. So if the probability of choosing something was 40%, then the probability of not choosing that thing, or the opposite, would be 60%. So and sometimes it's just easier to deal with the complement as opposed to the number that's being asked. And I'll show you some examples of that, but we're just going to find the complements for now. Find the complement of rolling a die and getting a 4. Well, rolling a die and getting a 4, that'd be a 1 out of 6 probability. So that means not getting a 4, there would be 5 out of 6. Selecting a letter of the alphabet and getting a vowel. So the complement of that would be not getting a vowel. So there are 21 consonants. So that'd be 21 out of 26. The probability of getting a green M&M out of a bag is 1 out of 6. What's the probability of its complement? Pretty much just did that on that previous one there. So the way to find a complement mathematically is always just subtracted from 100%, or if it's a fraction, subtracted from 1. So it'd be 5 out of 6. All right, experimental probability. So experimental probability is what does happen. Again, take a coin, flip it 10 times, get heads 67 times. The experimental probability would be 60%. All right, so let's use this example. In a sample of 50 people, 21 had type O blood, 22 A, 5 had B, and 2 had type AB. Find the following probabilities. So a person has type O blood. So out of the 50 people, 21 of them have O blood, so that'd be 42%. A person either with type A or type B. This is not type AB. This is either A or B. So there are 22 that have A, 5 that have B, so 27 out of 50. So that would be, 54%. And then a person does not have AB blood. Well, if there's 2 that do, that means there'd be 48 that don't. So that'd be 96%. All right, a couple of last things here. Law of large numbers. More times you run an experiment, the more likely the results will become the actual probability. So, like if I flip a coin and I flip it 2 times, there's a real good chance that I'm going to get both heads or both tails. And if I flip it 10 times, how likely is it that you're going to get 5 of each? You might. There's a good chance that you won't. But if I flip a coin 1,000,000 times, what's the probability of me getting, say, 700,000 tails? It's not very high. The more times you flip it, the more times you are likely to be to where it's supposed to be. That's what the law of large numbers are. So, doing something only a couple of times, there's a good chance it won't be what it's quote unquote supposed to be. Do it more often and you will. All right, and then the subjective, like I was talking about earlier, if it's what you think, for instance, if you're a Bears fan, you might think that the Bears have a 25% chance of winning the Super Bowl next year. That's probably a generous probability, but nonetheless, if you're a Super Bears fan, maybe you think that. All right, so that is lesson 10 from Unit 3. Let me know if you got questions.